All right. First one of math like this. First lesson for chapter 6, trigonometry, which is quite different from what we've been doing. Some of you can breathe a sigh of relief, but that other stuff is still going to rear its head later, so it doesn't mean it's done. Anyways, chapter 6, trig, 5 lessons. I had study day, test, who knows, blah, blah, blah. I think the beginning of next week is when I will kind of give you a rubric. The beginning of next week at the latest, kind of a rubric of how to kind of, I'll do this for physics and PreCal, to how your kind of project for the unit will be. And if you decide not to do a project, you don't hand it in by the due date, then it will be a mandatory test when you get back. And it'll be like right after you get back. I won't give it to you day of, but second day. Alright. Anyways, so that's the first slide, and I didn't double-side these ones. Here we go. Where is it? So you can pause that, and then you can write it down. Okay, good writing. 6.1 angles in standard position in quadrant 1. What's quadrant 1? For those of you that don't remember, there's 4 quadrants. 1, 2, 3, 4. Yes, it goes counterclockwise like that. So an angle in standard position is made up of 2 arms. The first is the positive x-axis, so it's this. This is the first arm. The second is called the terminal arm. So wherever that goes, we're talking about though in quadrant 1, that'll be in here somewhere. So let's just say it's here. That's the terminal arm. The angle is measured from the first arm to the terminal arm in a counterclockwise fashion. So it goes like this. That's how you measure it. The reason it says counterclockwise is because later on, if we have an angle like this, it'll be a straight line. Weird, just bends on its own. Then you measure it this way. That's how you measure it in standard position. Alright? So many notes. I'll let you take that down. So we will need everything we know from SOHCAHTOA and the Pythagorean theorem. If you don't remember that stuff, sine is opposite over hypotenuse. It's opposite over hypotenuse. Cos, adjacent over hypotenuse. And tangent is tan of theta, which equals TOA, opposite over adjacent. Pythagorean theorem, a squared plus b squared equals c squared. You can't see that. A squared plus b squared equals c squared. That's Pythagorean theorem. These are your 3 trig ratios, 3 primary trig ratios. Okay, new to us, the Pythagorean identity, which is the cos of theta squared plus the sine of theta squared, that equals 1. Put that into Desmos, just for fun. I'll just tell you that. Put that into Desmos and see what comes up. Tan of 45 degrees is 1, because with a 45-degree angle, so if that's 45 degrees, then this side is the same as this side. Both sides are the same, 45 degrees. So the opposite over adjacent is going to equal 1. Like, so if it's 16 over 16 or 38 over 38, if it's 45-degree angle, these two are the same. Sine of 45, this is the root of 2, just 2 over 2, equals the cos of 45. The root of 2, not the root of 2 over 2, not the root of the whole thing. So to be clear, I'll write that down right here. It's a root of 2 over 2, okay? Not the root of the entire shooting match. All right. And that's with, again, with a 45-degree angle, the sine of 45 degrees and the cos of 45 degrees, they are going to equal the same thing. We're going to do the check your understanding, page 428, 1 and 2. You're going to do 431, 3 to 14. Put a line here so I know that's where I left off. Cool. It's weird when I don't have that auditory feedback. How do I know if it's cool? Everybody just needs to text saying cool. Even if you don't mean it, it'll just make me feel good. Talk to myself here. All right. CYU. Number 1. Page 428. It says the point P 3, 4. Okay, so it's giving us a point. It's just giving it a letter to kind of identify it. If there are a bunch of points somewhere, P, Q, R, doesn't matter. This is just a point. These are the coordinates of that point. This point is on the terminal arm of an angle in standard position. That's a positive 3 and a positive 4. So on the grid, it's like 1, 2, 3, and then 1, 2, 3, 4. That's the point that it's talking about. All right. Now it says determine the distance r from the origin to P. So what is this? Well, this, my friends, is the hypotenuse. A squared plus B squared equals C squared. A is 3, B is 4. So A squared plus B squared equals C squared. No skipping steps, Morris. 4 squared equals C squared. 3 squared is 9. 4 squared is 16. Equals C squared. 9 to 16 is 25. That equals C squared. So you take the square root of both sides. 5 equals C. Now normally you say plus or minus 5. This is a negative 5. All right. 5 equals C. So it says determine the distance. It's 5. The distance is 5. There's no units given, so it's just 5. Cool. B says determine the primary trig ratios of theta. Okay, so remember, SOHCAHTOA, sine of theta equals, so opposite over hypotenuse. So the opposite side here, from this angle, remember this is the angle we're talking about, and you can't see what I'm talking about. This angle, that's theta. Why did I draw this so small? I don't know. That's the angle we're talking about. So the opposite side is 4. The hypotenuse is 5. I feel like I'm yelling. Sorry. Cos of theta is adjacent over hypotenuse. Adjacent side is 3. It's really warm in here. Hypotenuse is 5. Tan of theta is opposite over adjacent. The opposite is 4. Adjacent is 3. Tan is the only time you're going to have an improper fraction where the numerator is bigger than the denominator, because the hypotenuse in a right angle triangle is always the longest side. Tan of theta does not include the hypotenuse. The top number won't always be bigger, but it can be. So these are our answers. When it's asking for primary trig ratios, you will get this throughout the unit, and longer into the future, people forget. These are the primary trig ratios. Alright. C. See, notice like I'm hitting the desk. That means this is important. It's simple, but it's important. Alright. C. Determine the measure of theta to the nearest degree. Okay, we can use any of these bad boys and just solve for theta. I'm going to use sine just because it's the top one. Doesn't matter, you get the same answer. So sine of theta equals 4 over 5. This, I think, was covered in grade 9 to start, so this should not be new. We just got to take the inverse sine of this. Theta equals inverse sine of 4 over 5. So on my calculator, lots of calculators are different, and by calculator I mean phone. It's going to adjust. So I'm going to hit inverse sine, and it just works like this. See, so it shows sine to -1. It's too bright. Sine to -1. I'm going to hit that, and then I'm going to do 4 over 5, because my calculator kind of does it like this. Then I hit equals 53 degrees. Does it say how many decimal places? To the nearest degree. 53 degrees. So theta equals 53 degrees. That will work out regardless of which one you use. Alright? That's CYU numero uno. Okay, numero 2. Got to keep up with my Spanish because we are going to Mexico eventually. Okay, word problems. Everybody loves a word problem. A forest ranger sees smoke rising from a point that lies in a direction east 40 degrees north. Somewhat familiar language for my physics peeps. She estimates that the distance from the ranger station is about 30 kilometers. The firefighters at the ranger station Have to travel east, then north to get to the fire. To the nearest kilometer, how far should the firefighters travel in each direction? All right, so let's draw this bad boy out so we know what we're looking at. She sees smoke rising from a point that lies in a direction east, 40 degrees north. So it says east first. So east, and then 40 degrees, so it goes up 40 degrees to the north. That is a weird shape I just drew. Anyways, she feels like this is 30 kilometers. So that's 30K right there. Now the dudes, the firefighters, have to go this way and then this way. So we need to figure out how long this leg is and how long that leg is. With the angle here, this is adjacent, this is opposite. Adjacent and opposite. So let's, tan is going to be able to do it all for us, I think. No, what am I talking about? Tan's not going to help us at all. We need the hypotenuse. So we've got to do sine and then cos, or cos and sine. Sine of theta is opposite. You might do OPP just so you're not thinking it's 0. Opposite over hypotenuse. Sine of 40 equals, the opposite is what we don't know, x, I'll call it, over 30. So it's just sine of 40 times 30 equals x. Make sure your calculator is in degree mode. Different calculators show it different ways. I know mine, for example, is in degree mode because it's given me the option to change it to radians. Now it's in radian mode, and rads is up there. We will be using radians next year? Yeah, I think it's next year. Anyways, so I need to do the sine of 40. So sine of 40, 0.64 to blah, blah, blah. If you don't have this, when you do sine of 40, some of you might be 40 and then sine, whatever. It's not in degree mode if you don't get this answer. So it's that times 30. 19. Does it want the nearest kilometer or something? 5 east and north to the nearest kilometer. Yeah, so it's 19. So east, they got to go 19 kilometers. Now let's figure out the north part. That's going to be that's the north part. Sorry, that's the north part, right? That was sine, that was north. Cosine now for the east part. Cos of 40 equals x over 30. Cos of 40 equals 0.766 times 30. 22.98, so that'll be 23. So east is a 23 kilometer jaunt. Can you dig it? I certainly hope you can. Like I said, to physics, but lots of you won't know that. If something's not cool about the way I'm doing this, if I'm going too fast or need more explanation with something, please give me detailed feedback. If you want something to change, I'm all ears. And also, as you're working on this, anytime you get stuck anywhere, something doesn't make sense, email or iMessage, and I'll be checking throughout the day. I will do video responses at the end of the day. Cool, 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 cool.